Welcome to the Explainer. So today we're going to completely demystify the core financial and operational models behind Microsoft Azure. Basically, we want you to confidently adopt the cloud without any nasty surprises. If you're looking to understand exactly how your cloud infrastructure is going to impact your bottom line and your uptime, well, you're in exactly the right place. Let's get into it.
Now, moving to the cloud is an incredibly exciting business decision, right? But it definitely comes with a brand new set of challenges. To avoid that unexpected sticker shock and, disastrous outages, you really have to master two distinct concepts. First, forecasting your spending, and second, guaranteeing your service availability. So, we're going to break this whole thing down into two distinct pillars today. We're calling them the wallet and the clock.
All right, Section 1, controlling the wallet and the factors affecting your Azure costs. So there are 6 main levers that actually affect your costs. First up, you have the basics, right? The specific resource type and the services you choose. But look a little closer at location. Azure is globally distributed. That means a server sitting in one region might cost significantly more or maybe less than the exact same server in another region. Then there's bandwidth. While inbound data transfers, so data going into Azure data centers, are generally free, outbound data that's leaving Azure is actually priced based on geographical zones. But hey, it's not just about what increases your bill, it's about what shrinks it. You can leverage reserved instances. This means committing to 1- or 3-year plans, which can literally slash your pay-as-you-go prices by up to 72%. That's huge. Or you can use the Azure Hybrid Use benefit. This is basically just recycling the Windows Server or SQL licenses you've already paid for on-premises and bringing them right into the cloud at a massively reduced cost.
Moving right along to Section 2, Tools for Predicting Azure Costs.
Now, the absolutely crucial point here is knowing exactly which calculator to use for your specific situation, because, frankly, they serve two totally different purposes. The pricing calculator, that's your go-to tool when you want to configure and price out brand new Azure resources. You just plug in the region, the tier, your billing options, and boom, it spits out an estimated monthly cost. On the flip side, the total cost of ownership, or TCO, calculator is designed specifically for migrations. It helps you build a solid business case by comparing your current on-premises infrastructure costs directly against what that identical workload would cost if it were running in Azure.
And to see how this builds an undeniably strong business case, let's just compare the numbers directly. On the top here, you have an on-premises cost of over $30 million. And a staggering 93% of that budget is eaten up just by maintaining the physical data center itself. Crazy, right? But on the bottom, that exact same workload is migrated to Azure for just under $595,000. The physical data center cost literally drops to 0%, which completely shifts your financial focus over to networking and storage. It is just a super powerful visualization to present to your stakeholders.
But look, forecasting is really only half the battle. Once your infrastructure is actually live, the Azure Cost Management Dashboard steps in as your real-time financial control center. This is where you track your actual spending against those estimates we just talked about. You can set really firm spend budgets, you can trigger automated alerts the very moment your costs exceed those predefined limits, and you can analyze these incredibly deep billing reports to see exactly where every single penny is going. It even gives you intelligent recommendations on how to trim the fat.
Okay, Section 3, Minimizing Spend, and how to proactively lower your Azure costs.
You can continuously optimize your wallet by actively pulling a few key levers. Start by listening to Azure Advisor. It constantly monitors your usage and will actually flag idle or underutilized resources for you to just shut down. So no more zombie servers eating up your budget. Also, if your business allows it, always try to choose lower-cost geographic regions for your deployments. Oh, and here is a massive pro tip. Strictly apply resource tags. By tagging your resources with, say, department names or specific project codes, you can instantly identify exactly who is owning and generating those costs. It's an absolute game changer for establishing clear financial accountability across your entire organization.
All right, let's pivot to Section 4, Controlling the Clock, Service Level Agreements.
So this brings us to Service Level Agreements, or SLAs, and I really want to emphasize this. SLAs are far more than just dry, boring legal contracts. They are strict, highly quantifiable performance targets expressed as literal uptime and connectivity guarantees, and they have teeth. If Azure fails to meet these promised uptime guarantees, a percentage of your monthly service fees can actually be credited right back to you. These guarantees range anywhere from a 99% guarantee all the way up to a highly resilient 99.999%.
Now, when you translate these percentages into actual time, the math becomes intensely real. I mean, when we say 99% uptime, that sounds pretty great in a casual conversation, right? But a 99% SLA actually allows for over 7 hours of downtime every single month. So ask yourself, could your business survive being completely offline for a full workday? Probably not. Notice how investing in an architecture that achieves a 99.999% SLA, which is often called 5 nines, leaves you with a mere 26 seconds of allowable downtime per month. That right there is the absolute gold standard for mission-critical applications.
But here's the catch. Azure doesn't just hand you an overall SLA on a silver platter. You actually calculate a composite SLA based on how you build your app. It's a really fascinating push and pull when you're designing an application. If you stack multiple complex services together in a long chain, or maybe you opt for free tiers that don't even offer an SLA, you're actually lowering your overall composite SLA because you're introducing way more potential points of failure. Conversely, if you actively invest in redundant systems or deploy your apps across separate availability zones, you drastically raise your overall SLA. Your design decisions literally dictate your uptime.
Which brings us to our final section. Section 5, Azure Service Lifecycles, from preview to GA.
You see, Azure introduces new features through a very specific lifecycle. Microsoft allows you to test out beta and pre-release tools during what they call the public preview phase. This is fantastic because it gives you a massive head start to evaluate new capabilities and provide feedback way before your competitors do. However, a word of caution, you generally should not run critical business apps on preview features. Instead, you wait until those features become generally available, or GA. When a feature reaches GA, it means the whole shebang is fully baked, heavily tested, SLA-backed, and 100% ready for full production deployment.
But with hundreds of services constantly moving from preview to GA, how are you supposed to keep up with it all? Well, you can keep a constant pulse on all these evolving products, life cycles, and roadmap details simply by visiting the Azure Updates page. You can search by keyword, filter by status, like in preview or now available, and you can even subscribe directly to its RSS feed to get updates pushed right to you. Honestly, it is the best possible way to future-proof your cloud investments.
So there you have it. We've explored the primary levers that impact your bill, from resource location all the way to reservations. We've looked at the calculators that predict those costs, the dashboards that manage them in real time, and the SLAs that basically act as an insurance policy for your application's uptime. Thank you so much for joining me on this explainer today. I'll leave you with this one final thought. Take a hard look at your architecture today. If a major outage strikes tomorrow, is Azure going to be writing you a check, or will your business be paying the ultimate price?